Hello and welcome to another Ginger Mathematician video. So today I'm going through my predicted paper for paper 2 on the iGCSE 0580 course, and this is for both February and May 2024. It is 1 hour and 30 minutes long, so this is how long you should give yourself to do this. And if you want to have a go at this by yourself, then do look in the description below. You can download a blank copy of this, and you can either do this beforehand and then watch the video, or you can do a question, watch the video, do the question, watch the video. I will leave that up to you. If you want extra guidance, by the way, this is out of 70 marks, then if you click on this link here, this will take you through to all my videos, iGCSE related, so you can really practice those key topics that appear in this video. The topics that I have chosen are the ones that come up the most often, so these are ones you really should be focusing on as well. Right, let's get started. So first of all, we need to write down the lowest common multiple of 8 and 12. The easiest way to do this is to write down our 8 times table. So we have 8, then 16, 24, 32, 40, 48. And now we're going to do exactly the same thing with 12. So we have 12, 24. Aha, we can stop at this point because notice we have a 24 here and a 24 here, so our lowest common multiple is going to be equal to 24. Again, if you're happy to just write down the answer there, then that gives you the 1 mark. Next one here is write down a cube number between 20 and 30. So a cube number here is a number times by itself 3 times. So for example, 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, so 8 would be an example of a cube number. We can do 1 times 1 times 1, that's equal to 1. 3 times 3 times 3, so let's think about that. 3 times 3 is 9, 9 times 3 is 27, and that is the number that we are looking for because we want the cube number between 20 and 30. So 27 is going to be our answer there. On to question 3 here. Let's zoom in slightly so you can see the questions a little better. We have to calculate this. Now you could just put this into your calculator directly. That's absolutely fine. But let's just show you the manual way of doing this. So we have 3 squared. So 3 times 3, that's equal to 9. And then we've got 2 cubed, which we actually worked out in question 2. So do use the previous questions to help you with subsequent questions later on. And 2 cubed was equal to 8. So then we get 9 minus 8, and that's equal to 1. Notice with these 2 mark questions, I will make the extra effort to write that 9 minus 8 step, just in case something goes wrong a bit later on. Okay, on to question 4 here. So Francie changes 209 euros and 90 cents into dollars with this exchange rate here of $1 is equal to 93 cents. And now we need to calculate the amount Francie receives. So we have the euros and we want to go to dollars. So if we're going to go in that particular direction here, we need to divide. So we take our number 209.9 and then we divide that by 0.93. Now before we do that on the calculator, we can always do a double check. We're expecting to get a bigger amount of money if we do $1 is equal to 93 cents. So we're expecting to get some extra money here. Okay, so I've got my calculator here very, very handily. So make sure you've got your calculator ready for this particular predicted paper. And we need to do 209.9 divided by 0.93. So we pop that into the calculator and we do divide by 0.93. And you'll see our number here is 225.698. Again, I'm going to write down all the decimals in my display to make sure that I've got that there. Again, always double check. And generally with money questions, we round to, in this case, the nearest cent. So we need to round the 2 decimal places, and that's going to give us $225.70. So let's pop that in. And again, we always want to make sure this makes conceptual sense. So euros here, again, are worth slightly more than dollars. So again, we should have more amount of dollars at the end. on to question 5 here. So writing 120 as a product of its prime factors. This is a phrase that comes up a lot on iGCSE 0580 maths. As soon as I see this phrase, product prime factors, I need to do a factor tree. So it needs to go into your mind as soon as you see this, do a factor tree. Now, what is a factor tree? So we have 120. We want to split this into smaller and smaller numbers until we get some prime numbers at the end. What do I mean by this? Well, 120 is the same as 12 times 10. Notice I'm multiplying these numbers to get the number above. And now we can split these again. So 10 is equal to 2 times 5. 12 is equal to 3 times 4. Again, you could have done 6 times 2. You'll still get the same answer at the end. Notice here that 3 is a prime number, 2 is a prime number, and 5 is a prime number. So we stop at that point. However, 4 is equal to 2 times 2. So make sure you break down every number possible here. And now all we do with these circle numbers is then multiply them together. So our product of prime factors is equal to 2 times 2 times 2 times 3 times 5. This could also be written, by the way, as 2 cubed times 3 times 5. Generally, you'll get the 2 marks for both of the answers put down there. Okay, and on to question 6. So we want to work out this particular standard form expression. Notice this line here, just to remind ourselves, is a divide line. So to make this maybe slightly less confusing, we could write this out with this kind of divide sign. This is a good way to prompt us to do the right calculation here. Now you could put this into your calculator, but sometimes questions like this require a non-calculator method. So to do this question, we need to first of all divide these numbers. So we do 4 divided by 8. We're dividing because of this big divide in the center. And then we want to divide the powers of 10. So 10 to the power of 3 divided by 10 to the power of minus 2. So 4 divided by 8, that's equal to 0.5. And if we do this part, be very, very careful here. So 10 to the power of 3 divided by minus 2. So we're doing essentially 3 minus 2. The divide, when we're working with small numbers, is going to be a minus. And 2 minuses next to each other is a plus. So actually we end up here with 5. So we get times 10 to the power of 5. However, this is only good for 1 mark, and the key thing here is we need it in standard form. At the moment, it's not in standard form because we have a 0.5, so we need to change this so this number is between 1 and 10. How do we do this? Well, I'm going to multiply this side by 10, but to keep the number the same, I want to divide this side by 10. What do we get if we do this operation? So we get 0.5 times 10, that's equal to 5. And then 10 to the power of 5 divided by 10 to the power of 1, essentially. We need to minus those indices, and we get our final answer of 5 times 10 to the power of 4. This is where it starts getting a little tricky. You need to read the question carefully to make sure you get all 2 marks. On to question 7 here. So we've got some algebra skills, which is very common on the paper 2. So we have a formula, and we need to work out the value of S when A is 0.9, that should be a 0.9, and T is equal to 4. So all we do is wherever we see an A, we're going to put a 0.9. Wherever we see a T, we're going to put a 4. Now at this point, you could just pop this into your calculator, but we could also use mental methods as well. So 0.9 times 4, well 9 times 4 is 36. We want 1 decimal place in our answer, so this becomes 3.6. Then we divide that by 2, and that's going to be 1.8. Notice 36 divided by 2 is 18, then pop the decimal in. Again, this can all be done on your calculator. Part B, however, cannot be done on the calculator. We need to rearrange the formulas. Again, very key topic you need to know. And we want to find T in terms of S and A. So what does this actually mean in real English? So at the end of the operation, we want t equals something. So we want the t on its own. How do we achieve this? Well, first of all, we have a divide by 2, kind of annoying. So the opposite of that is times 2 on both sides. This cancels, giving us a t, and then s times 2 is equal to 2s. Make sure your 2's and s's look very different. Then, however, we want t on its own. We have a times by a next to it. So what's the opposite of timesing by a? We want to divide by a on both sides. This cancels, giving us t here, and then we get 2s over a. When we write a division with algebra, it's better to write it as a fraction rather than using this division symbol here. So all we need to write down for our 2 marks is 2s over a. Perfect. So question 8 here. So we want to write down the next term in the sequence, the very common question here. So notice here we've actually got a geometric sequence. What do I mean by that? Well, notice we actually are multiplying each time here. We're timesing by 3 each time. One of the biggest mistakes you can make in the exam is thinking it has to be an adding or subtracting. It's not always the case. So to work out the next term in the sequence, we need to work out 135 times 3. Now, in this exam, you have access to a calculator, so we can just literally type it in, 135 times 3. Again, we don't want to make a silly mistake. That gives us then 405 for our 1 mark. Then we've got this part, so 39, 32, 25, 18. We want to find the nth term of this sequence. This time, however, we do have an adding and subtracting sequence. We are minusing 7 each time here. So our nth term is going to equal here minus 7n, because we have an n for the nth term. And then what do we do to minus 7 to get to the first number of 39? So what I'm asking here is minus 7 plus what gives me 39, and that's going to equal plus 46. Again, we can always double check this. 46 minus 7 is 39. You can write it both ways round. So I generally leave it like this, but if you wrote down 46 minus 7n, that's also fine as well. If you need more practice on this topic specifically in sequences, I've recently started my iGCSE Maths exam workshop. So if you're interested in that iGCSE Maths exam workshop course, then I'll pop a link in the description so you can look through that. And there's a few topics on there that come up a lot. Sequences is one of them, and you may find that useful for that last minute revision before your exams. Right, question 9 here. So without using a calculator, the classic fraction question, work out 4 1/5 plus 7 over 9. Show you're working and give your answer as a mixed number in its simplest form. Okay, so we've got 4 1/5 plus 7 over 9. Even though we have to do this without a calculator, we could always use the calculator at the end to check we have the right answer. So we'll come back to that in a moment. First thing we need to do here is change this to an improper fraction. So to do that, we do 5 times 4, which is 20, add 1, that gives us 21 over 5. And now we have 2 fractions we can work with at this point. And the key thing here is to write both fractions with a common denominator. Now, how do we work that out? Probably the easiest way is just to do 5 times 9 is equal to 45. So we can write both fractions out of 45 here. And now we need to work out what we multiply the top of the fraction by. So what do I multiply 5 by to get 45? Well, I'm going to times by 9. So I do the same to the top. I'm going to be doing 21 times 9. Again, we can always use a calculator for these small calculations. That's absolutely fine. So if we do 21 times 9, that's going to give us 189. So we pop that up here. On the other side, however, what do we do to 9 to get to 45? We're going to multiply by 5. So we do the same to the top. We do 7 times 5. That's equal to 35. Now we have the same common denominator. All we need to do is just add the top of the fractions together. So we get 189 plus 35. Again, you can always use calculators to do this simple arithmetic. That is absolutely allowed as long as you show you're working. So here we get 224 over 45. And in fact, you could use your calculator at this point. So if I put this into my calculator, 24. So let's try again. 224 divided by 45 is equal to this part here. But notice I can actually change this between decimal and fraction, which is quite useful. So if we check this with our final answer, if we want to write this as a mixed number, how many 45s go into 224? We have 4 of them, because 45 times 4, if we quickly work this out, is equal to 180. How much do we have left over? Well, we have a 44 over 45. Now notice, if I just typed in the original question here, so say I just typed in 4 1/5, or even we could just take the 21 over 5, that's probably easier. So using the fraction button, 21 over 5 plus 7. This is a useful exam skill here. Notice we get exactly the same answer. So it's good to check this, even though we don't use a calculator to do this and we had to show our working, which I've done for all 3 marks. Nothing stops you from using your calculator to double check you're getting all 3 marks. Okay, on to question 10 here. So we need to simplify 3x cubed all squared. This is a question that students often get wrong. And the reason for this is this squared applies to both the 3 and the x cubed. So the way I would write this is we have 3 squared and we also have x to the power of 3 all squared. Separate it out, it's very important. 3 squared is equal to 9. X to the power of 3 all squared is equal to x to the power of 6. With brackets, we multiply those small numbers together. So we get 9x to the power of 6. And on to question 11. If you're liking this video and it's been really useful to you so far, then please do subscribe and press that like button so it can spread to as many students that need this help. Right, on to this one here. So the scale of the map is given as 1 to 125,000. And on the map, the length of an island is 5.7 centimeters. And we need to find the actual length of the island, again, giving our answers in kilometers. So what does this scale actually mean here? Well, we have 1 centimeter to 125,000 centimeters in real life. Now, this is a nice conversion to remember, particularly when a map scales question, is 100,000 centimeters is equal to 1 kilometer. You can build that up from 100 centimeters is equal to a meter, 1,000 meters is a kilometer, so 1,000 times 100 gives you 100,000. So we can actually convert the right hand side into kilometers by just dividing by 100,000. So what we're saying here is 1 centimeter on the map is equal to 125,000 divided by 100,000 kilometers. So if we get the trusty calculator out here, just to show you, so we take that number and then divide by 100,000. This then gives you 1.25. So all we're saying here is that 1 centimeter on the map is the same as 1.25 kilometers in real life. So to work out the answer, because we've got 5.7 centimeters, we just need to multiply both sides by 5.7 to then work out the actual length of the island. So we pop this answer in. We can use the answer button, always very helpful, then times it by 5.7. That then gives us 7.125 kilometers. So let's pop that in down here. I realise I say pop in quite a lot. I've noticed this over the last week or so. So our answer here is 7.125 kilometers. With a question like this, I would actually put the exact value. Again, you should probably be okay with rounding to 7.13 kilometers. Right, on to question 12. So Derek here invests $5,000 in an account that pays compound interest, that's important, compound interest, at a rate of R% a year. And at the end of that 5 years, he has then got this amount of money in interest, which is important. So not the total, but how much he has in interest. However, we can still work it out in exactly the same way. So if we want to work out the total amount, generally speaking, we start with the original. We then multiply by what I like to call the multiplier, so the decimal that basically includes the increase of what's going on percentage-wise to the power of number of years. Now, let's convert this carefully into what we need to work out. Now, the total amount of money he has is $5,000 plus the interest, so $7,693.12. The original amount is 5,000. The multiplier we don't know, so let's just give it a letter. Let's just call it A. And then number of years we're told is equal to 5. So actually we have a reasonable equation here to actually solve, basically making A the subject. How do we do this? Well, we've got to times 5,000, kind of annoying. So we're going to divide by 5,000 on both sides. This cancels, giving us A to the power of 5. So we just need to divide the other side by 5,000. So we have 7,693.12 divided by 5,000. That gives us this rather random decimal, 1.538624. So I'm going to put dot, 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 because we're going to use that answer in a moment. And then what's the opposite of to the power of 5? Well, we want to find the fifth root of both sides. So let's see on the calculator where that is. This cancels, giving us A. And now we need to do the fifth root of what we just worked out, 1.538. So let's pop that into the calculator so we can use the answer button here. So we go first of all shift this button so we can put in the fifth root, and then we want to put in answer, and there we get 1.09000. So let's write that down like so. And now we need to work out exactly how much the interest is. Well, remember how the multiplier is made up here. First of all, we can just times this number by 100, which gives us 109.000. And the key number here is this 9. That represents the percentage interest in this question. So R here is equal to 9%. And now we know that Derek actually had a rate of R% per year. Okay, and on to question 13. Unlucky for some, but not going to be unlucky for us. So we've got the diagram showing the points here, -1, 4 and 10, 8. And we want to find the equation of the line perpendicular to this that passes through this point 0, 1/4 in the form y equals mx plus c. As soon as you see a coordinate geometry question like this, the first thing you should be thinking here is gradient. So we need to work out the gradient of this line up here. Remember our formula, y2 minus y1 over x2 minus x1. So let's label these coordinates. So this is x1 and y1. This is x2 and y2, and we just substitute them in. So we have 8 minus 4 divided by 10 minus -1. So be careful with the two minuses. 8 minus 4 is equal to 4. 10 minus -1, so 10 plus 1, that's equal to 11. However, we want the line perpendicular to CD, so we need that negative reciprocal. I'm sure you've heard your teacher many a time using that lovely phrase. Now, what does that actually mean? So we take the fraction, we flip it, and then change the positive to a minus. This tells us then the gradient of the perpendicular line. So we know then it has the general equation of y equals -11 over 4x plus c. Now normally on these questions you substitute in this coordinate to then work out the c, but notice we actually have the y-intercept already here. Because x is 0 and y is a quarter. That is the y-intercept. So we can just replace the c here with a quarter and we have the answer. Y equals minus 11 over 4x plus a quarter. I'm trying to teach you these key exam skills. This could have saved you 1 minute or 2 minutes in the exam that could have made the difference to get other marks elsewhere. Okay, and on to question 14 here. So we need to describe fully, that's a really key word here, the single transformation that maps triangle B onto triangle A. Now, whenever we read a question like this, it's always very crucial to work out triangle B to A. So we're going from this triangle to this triangle here. The first thing to notice is we do have a rotation, so we have a turn of some kind. So we need to write down that keyword rotation. Then we need to think about the angle here. Again, we've got a quarter turn, so that's going to be 90 degrees. And then we need the direction here. So notice we need to decide either clockwise or anti-clockwise. So notice here we've got clockwise following the clock, or we've got anti-clockwise. So we need to pop in the anti-clockwise here because we're going against the clock, so to speak. And then we need to decide the center of rotation, so where are we actually rotating from? So we need to determine that particular point. Now, tracing paper is the best way to do this, so do ask in the exam for tracing paper. They will give that to you. However, there is another method we can do here. We take a point on both shapes that's the same and then see if we can actually find a right angle between the gradients of them. Now, that sounds quite tricky, but let's show you what I mean by this. If we take the point 0, 0, if I draw a line to 0, 0 here, and I draw a line to 0, 0 here, notice they meet at a right angle. If they meet at a right angle, that is your rotation point. So you may have to do some trial and error there to work out exactly which rotation point it is. But notice we've got 0, 0, and generally it's going to be an easy point, so 0, 0, 1, 0, 0, 1, so it's going to be usually whole numbers for this kind of question. This generally comes up on paper 4, but it can come up on paper 2 from time to time. This question, however, is much more typical for paper 2, so simplifying this here. Now, whenever I've got two quadratics, I start with the easiest quadratic, which is the one on the bottom here. So if we take 2x squared minus 18, it looks like it could be a difference of 2 squares, but notice that 2 and 18 aren't square numbers. However, if we do some factorizing here, if we take a factor of 2 out of each, what do we have left? What do I multiply 2 by to get 2x squared? X squared. What do I multiply 2 by to get minus 18? Minus 9. And now notice we do have a difference of 2 squares. DOTS, dots. Now, what does that actually mean? Well, we can factorize this really easily into 2 brackets. So what we do is put an x at the start. Now we look at the 9. The square root of 9 is equal to 3, so we can just put 3 in both brackets and we need 2 different signs. If you're stuck on a question like that, I suggest you check out my iGCSE algebra video where I go through a lot of questions like this. So we've got the bottom factorized here at 2 brackets x minus 3, x plus 3, and now it's time to factorize the top. Now, even though we could use a splitting the term method, we can do a little bit of working backwards to get to the answer fairly quickly. We have a 2x squared here, so we need to have a 2x and an x in our brackets. Then I know I'm generally going to get one of these 2 brackets in the numerator, so either a minus 3 or a plus 3. Therefore, there needs to be a 3 in here of some kind. Because we want to get a 3 here, what 2 numbers multiply to give me 3? Well, only 1 and 3. So this needs to be a 1. This is a 3. Notice we have a negative here, but we get a positive at the end. The only way we can achieve that is have a negative 1 and a negative 3. So without actually having to do any real calculations here, we actually got to the right answer. Now, if you're not sure, is that actually the right answer in the exam, you can always expand your brackets to double check you do get that quadratic at the end. Once we've done that, we can cancel x minus 3 top and bottom. That leaves us with our final answer of 2x minus 1 over 2x x plus 3. This video is not just important for a predicted paper, but how I'm thinking about the questions, where I can take those efficient shortcuts to save you time. On to question 16 here, we need to write 0.172 recurring as a fraction. So this fraction here is equal to 0.1727272. So it's the 7 2's that are repeated over and over here. Our strategy is to try and get the recurring parts, the same recurring part, after the decimal. Now, how do we do this? So I'm going to times both sides here by 10. You're probably wondering, why have I chosen 10, or why do I choose 1,000? Again, we'll see the logic as we go through. So 10 times x is equal to 10x. If I times this by 10, the effect is we move everything in one decimal place. So we get 1.727272 ... Now I'm trying to achieve the same pattern after this decimal pattern here. The way I do this is I'm going to work out 1,000x. Not 100x, but 1,000x. So I'm going to times both sides by 100. Now, why am I doing this? Well, if I times by 100, we're going to get a movement once. Twice, that gives us 172.727272 ... The reason is, if I put the 10x down below, if I minus one pattern from the other, so I subtract it, 1,000x minus 10x is 990x. If I subtract this part, notice the 727272 cancels in both, and all I have to do here is 172 minus 1, which is 171. All the recurring part disappears, and we're left with an easy equation to solve. So x here itself is going to be 171 over 990. However, this is not the final answer because we need it in its simplest form, and in fact you could try and look for common factors, but a very nice effective way of actually finding the simplest form is just use the calculator here. So if I type in 171 divided by 990, notice your calculator can simplify for you automatically and give you the correct answer here of 19 over 110. So again, 9 goes into both, that's how you would simplify, but you can use your calculator as an aid for some of these more straightforward tasks here. On to question 17, and we need to solve this quadratic here, showing all our working and answer to 2 decimal places. As soon as I see this, factorizing, which is my usual method here, is not going to work, or very unlikely to work. So I use my second method, which is the quadratic formula. Again, something you should know off by heart at midnight or any other times. So the quadratic formula is x equals minus b plus minus the square root of b squared minus 4ac all over 2a. How does it actually fit with the quadratic we have here? Well, we have a 1x squared, a plus 4 and a minus 11. So if I write this out here, the a represents the number in front of the x squared, the b represents the number in front of the x, and c is our constant term, the minus 11. So we pop this into our formula. I said pop it in again. X is equal to minus b, so minus 4, plus minus the square root of b squared, that's 16, minus 4 times 1 times minus 11, all over 2a. 2 times 1 is equal to 2. Right, let's sort out this square root stuff. So we've got minus 4 plus minus. Let's think about this carefully. So we have 16 minus 11 times 4, that's minus 44, all over 2. So that means minus 4 plus minus the square root of, or 16 minus minus 44, that's going to be plus 44, which is 60, all over 2. Notice if you made a mistake here and got a negative number, you know you've done something wrong. Go back and check your algebra. It's important to identify points where you could make a mistake, and if something weird happens or strange happens, then it's a good hint to go back and check your algebra. At this point, we just want to work out our two different answers. So we want to work out x1, which is minus 4 plus root 60 over 2, and x2 will be minus 4 minus root 60 over 2. And this is where the calculator comes in very handy. So at this point, we just type these things in. So we've got a fraction button, minus 4, we'll start with the plus root 60. So know where your square root button is, just here. And then we've got divided by 2. So we get it as an exact value here, but then we can go SD, and that gives you 1.87 to 2 decimal places. So we have 1.87. And then if we go back to our calculator again, we do a very similar thing, minus 4. Now we're going to go with minus root 60. So shift here, 60. And you really need to know your calculator here and use it nice and smoothly. And here we get minus 5.87. So we pop those two things in like so for the 4 marks. On to question 18 here. So we want to factorize completely. That's an important word. So for this question, for example, just taking out a common factor of x will get you 1 mark, but we want to get all 2 marks. So what do these two things have in common? Well, what number goes into 6 and 21? That's a 3. What letters go in? Well, we have an x squared and x cubed, so we can take an x squared out here. Now we just work backwards. So what do you multiply 3x squared by to get 6x cubed? 2x. What do we multiply 3x squared by to get 21x squared yz? So we have a minus 7, and don't forget the yz left over. So we get 3x squared, open brackets, 2x minus 7yz. On to part B here. So notice this is in a very peculiar form. This is in a so-called splitting the term form. So they've set this up in a very particular way you need to be aware of for the exams. The way to do this is to separate this into 2 separate parts and then factorize into single brackets. So I'm going to take a minus 1 out here. What do we get left over? Well, minus 1 times what gives me 4? Minus 4, that's a 4. What minus 1 times something gives me minus x, that's a plus x. So what I'm hoping for here is our bracket to also be 4 plus x. So what common factor do I have here? Well, I've got a 3 here, 3 goes into both, and an x. Let's work backwards now. So what do you multiply 3x by to get 12x? We get 4. What do you multiply 3x by to get 3x squared? That's going to be an x. Good, we've got exactly what we wanted here. We have the brackets the same. So now the factorizing is really easy. We have a 4 plus x. Whatever's left over, so the minus 1 and the plus 3x, we just put into the other bracket. Now the great thing about this kind of question, and this is the answer here, if you think something is not quite right or gone wrong, you can always expand out here to then double check you do get back to the original question, guaranteeing the 3 marks for the question. Okay, on to number 19 here, and on the diagram we need to sketch the graph of y equals sine x between 0 and 360. You do need to know these graphs off by heart, sine, cosine and tangent. So the first thing to establish here is that we've got 90, 180, and 270. So these are the critical points to sketch the graph. We start at 0, 0 for sine. We go up to 1 at 90. We come down to 0 at 180. We go down to minus 1 for 270, and then back up to 360 at 0. So make sure you've labeled the key points here and make sure you've got a nice smooth graph. From this graph, we want to solve 5 sine x equals 4 between this particular domain. So we want the sine x on its own. So what's the opposite of timesing by 5? Dividing by 5 on both sides. This cancels, giving us sine x, and that's equal to 4 divided by 5. Now, how do we interpret this in terms of the graph here? Well, 4.5 is the same as 0.8. So notice we're looking for the solution around here and around here. So this is what we want to read off to work out our two answers. We need to find the first answer here. So we need to get x on its own. So the opposite of that is the inverse sine on both sides. This cancels, giving us just x, and we work out the inverse sine of 4 over 5. This is where the calculator comes into its own. Now, whenever you start this, make sure it says d or degrees at the top, otherwise bad things happen. So we have shift sine inverse of 0.8 or 4 over 5. That gives us 53.130. So 53.13 ... So that's our first answer from the graph here. But we also want this one here. The way we work this out, because of the symmetry of the graph around 90 degrees, is that we can just do 180 minus this answer, 53.13. And that will give us the second answer using the graph to help us. So if we do 180 minus that answer, that gives us 126.86. ... So we want to round this to something sensible. So 53.1 degrees and then 126.9 degrees. Again, you'll get that extra mark for making sure you write down the rounded answer that is appropriate. On to question 20. So y is directly proportional to the cube root of x. Again, key information here. So let's write this out. So y is directly proportional, so no fractions involved here, the cube root of x. So if we translate this into an equation, we get y equals some constant k times the cube root of x. Now, to work out that k, we have some initial conditions. When y is 6, x is equal to 27. So we pop it in. So y is equal to 6. K stays as it is. And then we have the cube root of 27. Now you can use your calculator to work this out. But the cube root of 27, so basically I want something times something times something is 27, where the something is the same. It kind of has to be 3 here. It's the only number that makes sense. So we get k times 3, and therefore k here is equal to 2. We're not finished at this point because we haven't answered the question. Find the value of x when y is 16. So we copy out this formula. Y is equal to 2 times the cube root of x. And now when y is 16, 16 is equal to 2 times the cube root of x. So we want the x on its own here. Times 2 is kind of annoying, so we want to divide by 2 on both sides. That gives us 16 divided by 2 is equal to 8. This cancels, giving us the cube root of x. Now what's the opposite of cube rooting? Well, we need to cube on both sides. This cancels, giving us what we wanted, which is x. And now we need to do 8 cubed. Now probably at this point of the exam, you might get a little bit tired. So in this case, just use the calculator. Just pop it in, 8 cubed, giving you 512. And that's going to save you some stress instead of having to work it out manually. On to question 21 here. So here we've got points on circumference of a circle. BOD is a diameter. BC and AC are both tangents from a point. Therefore, that means they're the same length, which could be important later on. Angle OCB is 34. Work out DOA. DOA, this angle here. Okay, notice tangents and radiuses meet at a right angle here. Notice these are also the same length too. So notice we actually have the same triangle. We have a so-called tangent kite here. So this means then that this also has to be 34 degrees. And angles in the triangle add up to 180. So then this needs to be 56 degrees. And since it's essentially the same triangle, both here will be 56 degrees here. And now we can work out the angle we're looking for, because angles on a straight line add up to 180. So to work out the angle, so angle DOA, we need to do 180 minus the two other angles, so 56 plus 56. Again, you can use your calculator, particularly towards, as you get tired towards the end of the exam. So take away two lots of 56, we then get the angle of 68 degrees. Again, showing you're working like I've done here, where the sides are the same, is very, very important to do. Right, on to question 22 here. So we have a rectangular box, so we've got a bit of 3D Pythagoras and trig here, given like so. The distances are on the diagram, and we need to find first of all BH, this blue line going across. Now, the way that you can do this is we can do Pythagoras in two steps here. So notice I can join H up with F here. So we have a right angle triangle of the base of our rectangle. So if we kind of draw this out separately, we essentially have a right angle triangle with 5 centimeters and 12 centimeters, and we need to work out FH here, so this length here. Now I like to recommend doing this in one smooth calculation. So FH here is equal to the square root of these two squared, so 5 squared plus 12 squared. Now you can pop that into your calculator, but hopefully you know your Pythagorean triples. So 5, 12, 13 is nice numbers that fit together. So FH here is actually just equal to 13 centimeters. Once we have this, we can actually make another right angle triangle with the BH. So again, if we draw this out slightly separately, we now know the base here is 13 centimeters. If I label up F, B, and H, FB is equal to 3 centimeters, and now we're looking for this side. We can do that in a very similar way to what we did before here. So to work out BH, we then do the square root of 3 squared plus 13 squared. This is where it's not a Pythagorean triple, so we do need the calculator to help us. So we pop in the square root of 3 squared plus 13 squared, and that's equal to, as a decimal, 13.341, and we can round that appropriately to 13.3 centimeters for our 2 marks here. Now we need to work out the angle FHB, so this angle here. Notice we've already drawn a very nice sketch here down below, which we can actually use to work out that problem. So we have 3 centimeters, got the angle we're looking for, let's call it theta, typical maths letter to call it, and we've got these 2 dimensions. So we could actually just use tan straight away. We don't have to rely on this answer here. So how do I know to use tan? Remember, if we label the sides here, the 3 is the opposite side of the triangle. This is the hypotenuse. And if we're using O and H in SOHCAHTOA, so that's an A, this is the adjacent side, this is the hypotenuse. So anything with TOA in it, TOA, is going to involve tangent. So we then know the tan of the angle is equal to O over A, opposite over adjacent. The opposite is 3 divided by the adjacent, which is 13. But we want the angle here. So what's the opposite of tanning something? Well, we want to do the inverse tan of both sides. This cancels, giving us theta. And then we do tan inverse of 3 over 13. Again, back to our calculator here to do the hard work for us. So tan inverse, and then we've got fraction 3 over 13. That gives us 12.99. Nice number to round here. So rounding again with 2 nines here, has to be careful. we then get 13.0 degrees. So 13.0 degrees for our 3 marks. Make sure you put the degree sign in as well. That's important to do. Okay, our last question here, so question 23, bit of indices, again, a very common topic, can either be a really easy question or a really hard question. So, first of all, we want to do 2/3 to the power of -2. So, let's get rid of that negative indice by flipping the fraction and then changing to a positive, so we square it. Now, if you square a fraction, we just square the top and we square the bottom. And that becomes then 3 squared is equal to 9, and then 2 squared is equal to 4, giving us 9/4. Now our last question here, again they've been putting more of these kinds of questions into the iGCSE exam. Again, we need to solve this equation, and generally you're not taught logs on this course, at least not yet until 2025. So the way to do this is I've got a 4 and an 8. Notice I can write 4 as 2 squared and 8 as 2 cubed. So wherever I see a 4, I'm going to put a 2 squared. Wherever I see an 8, I'm going to put a 2 cubed. Now at this point, we can actually use our index rules to simplify this further. So we get 2 to the power of 2x is equal to, now think of this like a bracket, so we can actually multiply out the bracket here. So we get 2 to the power of 3x, 3 times -1 is -3. The whole point of this process is we've got the base is the same, therefore we can say that the indices must also be the same as well. So we can say 2x excuse me, is equal to 3x minus 3. And now we just have an equation to solve here. So we can add 3 on both sides. That gives us 2x plus 3 is equal to 3x. This cancels. And then we can minus 2x from both sides. This cancels, giving us just 3. And then 3x minus 2x. The answer just pops out here. So x is equal to 3 in this particular case. Okay, so hopefully that was really clear for you and helping you really revise very thoroughly for the exams that are coming up here. And if you want to revise all of iGCSE Maths Paper 2, so you want to go through for the next 2 hours the really important topics, and do check out the video in front of you. I spend a lot of time going through very carefully the topics that you've seen actually in this predicted paper as well. And if you are interested in the iGCSE exam maths workshop, then check out the link in the description.